Forget the shimmering blue marble, the verdant continents we cling to. That image, seared into our collective consciousness, is merely a fleeting snapshot of a cosmic truth far stranger. For eons, stretching back into the deep time before complex life dared to dream, our planet wore a different face. A face so alien, so profoundly ancient, it would redefine everything you thought you knew about Earth's vibrant past. What if, instead of the familiar green, our world was a swirling, alien, unapologetic purple? And what terrifying, brilliant secret does that forgotten hue scream about life's earliest, most desperate gambits? Look closely at our world today. What defines the vast forests, the sprawling grasslands, the very algae in our oceans? A relentless, vibrant green. This isn't just a color, it's a signature, the unmistakable calling card of chlorophyll, the molecular engine that powers nearly every breath you take, every bite you consume. It's the ultimate solar panel, a molecular machine that devours sunlight, ripping apart water molecules, exhaling the oxygen that defines our atmosphere, making our existence possible. But here's the cosmic twist, the mind-bending secret history locked away in the very rocks beneath your feet. Green wasn't always the dominant hue. Billions of years ago, when life was just a desperate whisper, a primordial chemical experiment, on a nascent canvas, Earth was a radically different place, a world utterly alien. So, the burning question screams across the eons, a cosmic cold case demanding answers. What color was Earth when life first clawed its way into existence, when the very first organisms began to harness the sun's savage fury? The prime suspect in this ancient palette swap, not plants, not even their distant bacterial cousins. No, the culprit is far older, far more primordial, a microscopic empire of organisms called archaea. Think of them as the ultimate cosmic survivors, the true pioneers of life, thriving in conditions that would obliterate anything else. And their secret weapon, their ancient solar panel, was not chlorophyll. It was something far simpler, far more ancient, a pigment called retinol. Now here's where the cosmic canvas truly gets interesting. Chlorophyll, the green stuff, is a master of absorbing red and blue light, leaving behind the green that paints our forests. But retinol, it plays a different game. It's a greedy consumer of our green light. Yes, the very light that chlorophyll rejects. And if you're absorbing green light, what color are you reflecting back into the cosmic void? A shocking, vibrant, almost impossibly alien purple. Imagine it, not just patches, not just oceans, but entire continents, entire shallow seas, shimmering with an unearthly primordial violet, a glorious, violent purple planet, screaming its existence into the early solar system. This isn't just a theory, it's the first clue, painted across the very fabric of our deep past. Now, let's peel back another layer of this cosmic onion and witness the silent, brutal energy war that shaped our planet's very color. At its core, the difference between chlorophyll and retinol isn't just about a pigment, it's about a fundamental strategic gambit in the relentless pursuit of solar energy. Chlorophyll, the green titan we know, is a sophisticated, highly specialized solar panel. Imagine it as a finely tuned instrument designed to perfectly capture the extremes of the visible spectrum, the fiery reds and the electric blues. It's incredibly efficient at what it does, extracting maximum energy from those wavelengths. But in doing so, it rejects the middle ground, the broad swath of green light, reflecting it back into the cosmos. That's why our world screams green. But the ancient, purple pigmented archaea, they were the ultimate contrarians, the rebels of the early energy market. Their retinol-based systems, though simpler, were built for a different battlefield. They didn't chase the extremes. Oh no, they were perfectly engineered to devour the one wavelength chlorophyll scorns, green light. Think of retinol as a cosmic credit card. Simple, universally accepted, especially where other, more specialized cards couldn't get a signal. In the primordial oceans, green light penetrated deepest, reaching the murky depths where these early life forms thrived, shielded from the sun's harsher UV radiation. While chlorophyll's ancestors were perhaps struggling near the surface, the purple archaea were plunging into the abyss, harvesting the abundant green light, reflecting a glorious, deep purple back. This wasn't just a difference in preference. It was an ancient, silent war for planetary dominance. For billions of years, the purple players held the tactical advantage. They were the first to master photosynthesis, deploying their retinal-driven systems across vast stretches of the early Earth, painting the shallow seas and microbial mats with their astonishing, unearthly hue. They were everywhere, the unchallenged monarchs of light harvesting, soaking up the green, and in doing so, they defined the visible color of our planet. The very air we breathe today, the very existence of complex life, might owe its origins to these purple pioneers who first cracked the code of solar power. They laid the groundwork, pushing the boundaries of what life could extract from a raw, untamed star. So, if your mind is already bending, if the very fabric of Earth's forgotten past is shimmering before your eyes, then hit that like button and subscribe to The Cosmic Strategist for more universe-shattering secrets. Because the cosmos, my friends, is always stranger than fiction, and the greatest stories are always found in the deepest, most unexpected corners of reality. But how do you hunt for a ghost that lived billions of years ago? How do you prove that our world once screamed purple when the very organisms responsible were microscopic, ephemeral, and existed long before anything resembling a fossil record we could easily decipher? This isn't like finding dinosaur bones. It's like trying to find the faded footprint of a single ancient ant on a planet that has since been utterly resculpted by volcanic fury, tectonic shifts, and the relentless grind of eons. The challenge is immense. It's a cosmic cold case, a detective story played out across geological time. Our cosmic detectives, the astrobiologists and geochemists, can't just dig up a purple rock and declare victory. Oh no, the evidence is far more subtle, far more insidious. They're searching for faded footprints, for invisible ink written into the very fabric of ancient Earth. They're looking for indirect chemical and isotopic signatures, the lingering whispers of a forgotten biochemical war. First, they turn to the geological archives, the ancient sedimentary layers that slowly, agonizingly record Earth's past. These aren't just pretty rocks. They're cosmic hard drives, storing data about atmospheric composition, ocean chemistry, and the dominant life forms of their time. The key here is to look for specific types of iron formations, or the ratios of different isotopes of carbon and sulfur. Why? Because the way early microbes processed energy and nutrients left behind unique chemical scars in the rocks. If purple archaea dominated, their metabolic pathways would have imprinted a distinct signature different from the later oxygen-producing green life. It's like finding a specific brand of cosmic tire track in the primordial mud. Then there are the molecular biomarkers, the true smoking guns if they could be found. Imagine finding the decaying remnants of retinal pigments themselves, or the unique lipids and fatty acids produced by these ancient purple organisms. This is incredibly difficult. Organic molecules degrade over billions of years, crushed by pressure, cooked by heat. But scientists are developing increasingly sophisticated techniques to detect these infinitesimal traces, searching for the ghostly echoes of ancient biochemistry. They're also looking for the absence of evidence. If early Earth was purple, then the characteristic chemical signatures of chlorophyll should be strikingly missing from the oldest rocks, suddenly appearing later, marking the rise of the Green Empire. Perhaps the most tantalizing clues come from spectral analysis. If Earth's early surface was dominated by purple pigments, then the light reflected from our planet would have a very specific spectral signature, a deep absorption band, right in the green part of the spectrum. It's like looking for the echo of a specific sound that has long since faded. While we can't directly measure the light from 3.5 billion years ago, we can build models of early Earth's atmosphere and ocean, and then calculate what kind of light would have penetrated and what kind of pigments would have been favored. These models suggest that green light would have been readily available, making it a prime target for early light harvesting systems. It's a compelling theoretical framework, a ghostly projection of a purple past. Finally, we look for indirect fossil evidence. While the tiny archaea themselves are rarely preserved, they often formed vast layered microbial mats much like the infamous stromatolites we see today in places like Shark Bay, Australia. These layered structures, built by successive generations of microbes trapping sediment, can fossilize. By studying the chemistry and microstructure of the oldest known stromatolites, scientists can infer what kind of life built them. If these ancient structures contain the telltale chemical signatures of retinal-based metabolism or show evidence of thriving in light conditions consistent with green light absorption, it would be a powerful piece of circumstantial evidence for the purple rain. This detective work is painstaking, often frustrating, but the potential payoff is immense. Every rock core drilled, every ancient isotope analyzed, every spectral model refined, chips away at the cosmic mystery, slowly revealing the truth about Earth's original, vibrant, and utterly alien color. We are piecing together a cosmic crime scene, searching for the perpetrators of a biochemical revolution that utterly transformed our world, painting it purple before the green conquest began. So, if purple was so dominant, so universally effective at gobbling up green light, why did our world ultimately become a swirling mass of green? Why did the chlorophyll empire rise to conquer the globe, pushing the purple pioneers into the shadowed, extreme niches where they still cling to existence today? This wasn't a sudden, cataclysmic overthrow. It was a slow, relentless strategic war, a cosmic chess game played out over billions of years, where one gambit proved simply more brilliant. The answer lies in a molecular superpower. While retinal-based systems like those of our ancient purple archaea were simple, robust, and incredibly effective at absorbing green light, they had a critical limitation. They were anoxygenics. They didn't produce oxygen as a byproduct. They got their electrons from other sources, like hydrogen sulfide, the rotten egg gas that permeated early Earth. But then a new player emerged, a revolutionary bioengine that changed everything. The ancestor of modern cyanobacteria, armed with chlorophyll, this new breed of microbial genius discovered a far more abundant, virtually limitless resource: water. Chlorophyll cracked the code of splitting water molecules, unleashing oxygen as a waste product. This was the ultimate strategic deep dive, the visionary's gambit that forever altered Earth's fate. It wasn't just about absorbing light, it was about what you did with the energy. The anoxygenic purple life was like a single-lane road, efficient for its time. The oxygenic green life was a superhighway, capable of processing vastly more energy and, crucially, transforming the planet's very atmosphere. What followed was the Great Oxidation Event, a planetary catastrophe for the purple world, and a revolutionary dawn for everything that came after. As the green machines proliferated, they began to pump out oxygen, molecule by molecule, until it saturated the oceans and then bled into the atmosphere. This was poison for most of the existing anaerobic purple life. Imagine a world slowly, agonizingly, choking on the exhaust fumes of its new green conquerors. The iron in the oceans rusted, falling to the seafloor in vast red bands. The sky itself began to shift from a hazy methane-rich orange to the familiar blue. This environmental reengineering was the crucible for complex life. Oxygen, once a toxic pollutant, became the ultimate fuel. It allowed for vastly more efficient energy production, paving the way for multicellularity, larger organisms, and eventually, the explosion of animal life. The purple world was the necessary nursery, teaching life how to harness the sun. But the green world provided the necessary atmosphere for life to truly breathe, to grow beyond simple microbial mats, to become the complex, diverse tapestry we see today. It was the ultimate rise and fall drama, where a simple chemical innovation utterly transformed an entire planet. But here's where the cosmic canvas expands, bleeding beyond our single familiar blue-green dot. If Earth went through a glorious primordial purple phase, what does this scream about the potential for life on alt exoplanets? If the simplest, most ancient forms of photosynthesis on Earth relied on retinol and painted our world purple, isn't it logical to assume that this efficient, robust, simple strategy might be ubiquitous across the galaxy? Imagine alien worlds, not with verdant forests, but with vast, shimmering purple oceans, continents covered not in green algae, but in deep violet microbial mats, reflecting an unearthly glow into their suns. This isn't science fiction. It's a profound implication for the search for life beyond Earth. When we gaze at distant exoplanets with our powerful telescopes, searching for the telltale red edge, the spectral signature of chlorophyll reflecting infrared light, we might be looking for the wrong color. Perhaps the first, most common, and most ancient forms of alien life aren't screaming green into the void. Perhaps they're whispering purple. Our cosmic search needs to broaden its palette. We should be looking for worlds that absorb green light, reflecting back that telltale violet hue. The universe, in its infinite wisdom, might be teeming with purple worlds, waiting for us to understand that our own planet holds the key to their hidden, ancient beauty. The ghost of purple Earth isn't just a fascinating historical footnote. It's a cosmic roadmap pointing us towards the true, unexpected colors of life across the stars. We began this journey challenging the very image of our home, the familiar green marble we cradle in our minds, and now the truth, or at least a powerful, ancient hypothesis, has painted a far more alien, more profound picture, a world bathed in an unearthly primordial purple. This isn't just a curious footnote in Earth's biography. It's a shattering revelation about life's earliest, most audacious gambits, a testament to its relentless will to exist. No matter the conditions, no matter the color, it screams into the void. The saga of Purple Earth, eventually giving way to the green dominance we know, is a cosmic drama. It's a testament to life's astonishing adaptability, its capacity to find a way, to rewrite the very rules of planetary existence, and to ultimately sculpt the atmosphere itself. It shows us that the universe doesn't just allow life, it demands it, crafting ingenious solutions to harness raw energy, to thrive in the most extreme conditions imaginable. And what does this mean for the countless worlds spinning in the cosmic blackness, waiting for our gaze? It screams a new truth. The universe might be bursting with life, not just in shades of green, but in a kaleidoscope of unexpected hues, waiting for us to broaden our gaze, to look for the colors we never dared to imagine. Every assumption we hold, every familiar image, is a potential frontier for shattering revelation. The cosmos doesn't just reveal its secrets, it unleashes them, forcing us to constantly rethink our place within its boundless, vibrant mystery. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.